Hey everybody, right here on the table I have the brand new Jackery SG HomePower 3000. Now this is actually the most lightweight and compact 3 kilowatt hour power station that I've tested on the channel. Now in order to demonstrate the size of the Jackery power station, I have a power station with a much smaller battery here. This is the Pecron E1500. The battery is half the size of the Jackery and the inverter is much smaller, but you can see they're basically the same size. Now this compact form factor is possible through CTB technology. Basically, Jackery integrated the battery cells into the case of the power station, saving on a bunch of space and weight. Now if you're somebody that's looking for a lot of power in a really compact package, and you also want the proven reliability of Jackery power stations since they've been around since the beginning, you're going to want to stick around to see how this one performs. Now before the testing, I want to go through the brief specification list for the HomePower 3000. They call this the HomePower 3000 because it is meant to be a simple plug-and-play home backup unit. Now at the heart of this unit is a 3072 watt-hour lithium iron phosphate battery, and to power everything is a 3600 watt pure sine wave inverter. You also have additional USB ports to power your mobile devices, and you have a 12 volt cigarette port to power some 12 volt loads. This power station does accept up to 1000 watts of solar input. It has a UPS backup functionality with an advertised cutover of 20 milliseconds. And of course, you have the ability to control this power station remotely via Jackery's smart app. Now, since this is a brand new product launch, Jackery is offering this for a discount for $19.99 or about 65 cents per watt hour, which is an excellent price for a Jackery power station. Now you guys know the drill. Throughout the remainder of the video, I'll be doing extensive testing on the power station so you guys can see the true performance. This is not a sales video. I am here to show you how it performs, and then if you guys like that performance, then you guys can purchase the power station. I understand that everyone has a specific use case and there are so many different brands and each person has their favorite brand. Now at the bottom of the video, there will be these chapters that you can jump around to if you want to see the performance in an individual section. Let's jump into the testing. First, I wanted to see if the power station could run the maximum advertised load for 15 minutes, which is 3600 watts. During this test, my oscilloscope was showing a pure sine wave output, and I measured 120 volts at 60 hertz. This is the same high quality power you'd expect to see from your utility company. After 10 minutes of running the maximum load, the cooling fans were at full speed. I measured 52 decibels with my sound meter at 3 feet away. Then I used my thermal camera to confirm the power station temperatures weren't getting too hot. I saw a peak of only 104 degrees Fahrenheit near the fan exhaust ports, indicating no signs of overheating. The HP3000 was able to run the full rated load for 15 minutes without shutting down. Now, what is the maximum wattage the inverter allows you to pull before it overloads? I turned up the load from our previous test till it got up to about 4600 watts and the inverter finally shut off. It's good to see the inverter does have a bit of leeway if you need to pull higher than 3600 watts before it shuts down. I also wanted to demonstrate how long the HomePower 3000 could run a portion of my house during an extended power outage. The power station was connected up to my transfer switch with all 10 circuits enabled, and up on the screen you'll see a breakdown of what's powered by that transfer switch. The power station ran for a total of 8 hours before it finally shut off, and during this test I saw an average of 300 to 500 watts being used, with the occasional jump in higher wattage as larger appliances were turned on. If you were looking for a longer runtime, you'd need to connect in solar panels to supplement your loads, since this power station doesn't support expansion batteries. Now moving on to our next test, I want to see how well the HomePower 3000 handles inductive or surge loads. Now in order to test this out, I'll be connecting up multiple inductive loads, starting with this 10 amp air compressor, moving up to this 12 amp vacuum, and then this 15 amp table saw. Now in order to measure the inrush current, I am connected to the 30 amp output, and I'll be using my Klein inrush meter to see how many amps each of these devices pull. So I'll be turning on the air compressor in 3, 2, 1. So it pulled a total of 24.68 amps on startup. Next, we'll be stepping it up to the 12 amp vacuum. We should see a little bit more amperage here. So the vacuum did pull more amperage, 32.10 amps on startup. Next, we'll step it up to the largest load, the 15 amp table saw. The The inverter powered up the table saw with no issues. It pulled 40.08 amps. Now as my final test, I want to try powering up the table saw and the vacuum at the same time. So I've wired in a switch here. Let's see if we can go over 40 amps and see if the inverter can handle it. Wow guys, check it out, 52.19 amps. That is a crazy amount of surge current, and the inverter handled it just fine. The Jackery HomePower 3000 does have UPS functionality, advertised to have a cutover less than 20 milliseconds. Let's test it out. Now I've started a stress test on the computer to simulate a workload. Both the computer and the monitor are plugged in along with my studio lights, and we'll track the cutover using my oscilloscope. First UPS test in 3, 2, 1, record. So here's the measured UPS cutover. It cut out right here and resumed right here, and the distance between these two cursors is 13.3 milliseconds. So it's advertised to have a 20 millisecond cutover, and it performs much better at 13.3 milliseconds. Now the computer is still running from the previous test, but let's just do a couple more just to make sure. So second UPS test, 3, 2, 1. Third and final UPS test, 3, 2, 1. So in the next test on the inverter, I want to see if it has a floating ground or a bonded ground. So I have the AC inverter enabled and my outlet tester is connected in, and we are getting an open or floating ground whenever this is not charging from the wall. Now I also wanted to make sure that we get the same results on the 30 amp output. Now what happens when you connect the AC charging cable? Well, the inverter picks up ground from the charging source, which is exactly what you want to see. And yes, we do get the same results on the 30 amp output. Now, does the inverter produce any interference? I measured over 2000 millivolts of EMI using my dirty electricity meter, indicating the inverter does generate a higher level of electromagnetic interference. But is that level actually audible? Connecting my guitar amp into the inverter, the EMI wasn't audible and I didn't hear any interference. Now, how much usable capacity should you expect when running loads off the inverter? I discharged the power station with a resistive load until the battery died and measured 2,820 watt hours of usable capacity. This result is 91.7% of the advertised capacity, which is an impressive result, definitely higher than average. And finally, how much power is used as the AC inverter sits idle for a long period of time? Leaving the inverter enabled for 12 hours, the state of charge had dropped down to 90%, meaning that the inverter only used 10% of the battery, or about 0.83% per hour. That's an excellent idle power usage for a large 3600 watt inverter. So now that we've completed the AC inverter test, let's briefly go through some highlights. First off, the power output is very clean. It's a pure sine wave at 120 volts. Also, we pulled up to 4600 watts before the inverter actually shut down. And as for the surge capability, we pulled 52 amps. So this can definitely handle some power tools without an issue. Now, even under the max load test, the fans weren't that loud at 52 decibels. There's definitely power stations that are louder. Now, as for the efficiency, I was also impressed. We got over 91% of the advertised capacity during our discharge test. And also, the idle power consumption was less than 1% per hour at 0.8% per hour, which is really good versus some other power stations that I've recently tested. And finally, if you are wanting to use this as a UPS, the cutover time was great at 13.3 milliseconds and the computer still kept running. Next, I want to move on to testing the DC output and USB ports on the HomePower 3000. Zooming in, we have a single 12 volt cigarette port, and right below that you have two 100 watt USB-C power delivery ports and two USB-A quick charge ports. And if you want to turn on the USB or the 12 volt output, you push this button right here. So let's start testing the 12 volt socket first. I have my load tester connected up, and we are getting a regulated 13.12 volts. Now the 12 volt cigarette port is rated for 10 amps, so I have my load tester set to 10 amps, and we are pulling 129 watts. Now how much power can we pull from the 12 volt socket before it shuts off from being overloaded? If you look at my load tester, it's at 13.1 amps. Let's turn this up to 13.2, just to see if we can go a little higher. Okay, so 170 watts. Oh, and right then it overloaded. So you can actually pull quite a bit of power from this 12 volt socket, up to 170 watts or right around 13.2 amps. Next, I want to test each of the USB ports. You can see we are getting power delivery 3.0 at 100 watts from the first USB-C port, and we're charging the power bank at 96 watts, pulling 101 watts from the power station. Connecting up to the second USB-C port, we are getting the same results. Now what about the two USB-A ports? Each one's rated at 18 watts. Looking at the USB tester, we're getting Quick Charge 2.0 protocol at 12 volts, and we are charging right around 18 watts. And testing the final USB port, we are getting the same results, Quick Charge 2.0 protocol at 18 watts. Now what about using all the USB ports and the DC output at the same time? How much power can you pull, and are there any issues? As we look closer at the screen, you can see we're pulling about 380 watts through both the 12 volt socket and the USB ports. I'm charging my cell phone and a couple power banks, and we're pulling 170 watts through the 12 volt output. So yes, you can use all of them at the same time, and you can get quite a bit of power. How much usable capacity can we expect from the DC output? Using my electronic load to discharge the power station, I measured a total of 2,759 watt hours as it turned off. These results were 89.8% of the advertised capacity. Now after testing the DC output, we did get decent results from the 12 volt cigarette port at about 169 watts. And also we got 89% of the advertised capacity during our capacity test. I will say that the USB ports and DC output are a little dated on this device. For example, with premium units these days, usually you're getting 140 watt power delivery ports, and we're also seeing some high DC output options. For example, instead of just a 12 volt cigarette port, we're seeing either an Anderson port that puts out 30 amps or an XT60 port that puts out 30 amps, and this one just doesn't have those extra features. In the next section of the video, I want to go through the charging options on the HomePower 3000. Now in the box you get a bright orange AC charging cable and the user manual. This does not come with any DC or solar charging cables or adapters. On the right hand side of the power station you have your AC charging port here. It's rated for 15 amps or right around 1800 watts. We'll test that out. And for the DC input you have two 80-20 barrel ports. Now these are rated for 12 to 60 volts and each one has an input limit of 12 amps or 24 amps combined for a total peak charging of 1000 watts. Now in the owner's manual, there is a note about using the DC charging ports. Essentially, they want you to have the same solar setup on each of the charging ports because they are wired together in parallel. So for the best performance, you're going to want to have matching voltage on each of those ports. So essentially, both of these charging ports go to a single 1000 watt MPPT solar charge controller. They do not operate independently. In addition to the charging ports, you also have two AC circuit breakers here that you can reset if you happen to pull over current on the AC inverter. So in the next test, I want to see how fast this will charge with AC input. I've connected the AC charging cable and we are getting about 1400 watts input. Now on this smart app, we do have it selected as fast charging mode and you have two settings. So let's set it to quiet charging mode. Now the goal of this charging mode is to essentially keep the noise under 30 decibels. So I'm guessing the charging speed is going to be a little variable here. We're down to 800 watts. I did see 700 watts. And as the power station heats up, it's probably going to drop down the charging speed even more. So it's nice to have this adjustability here if you want to have silent charging. Let's go back up to fast charging mode. And I just want to see if we can get higher than 1400 watts because the port says it's rated for 15 amps, which is around 1800 watts. And this is a really large battery, so 3000 watt hours, I'd hope to see the full 1800 watts charging. But setting to fast charging mode, you can see we're topped out right around 1400 watts. Now what about the DC input on the power station? Let's go ahead and test that out. I have my 1200 watt adjustable power supply here, and to simulate a 12 volt battery, I have it set to 13.5 volts, and I have the power supply set to 25 amps, but the power station is limiting the input to slightly under 8 amps. And this is what it states in the owner's manual. Whenever you're charging from a 12 volt source, it's going to limit the input to 8 amps, even if you have both of the charging cables attached. So we are charging at 100 watts, and this will take about 30 hours to completely charge the power station if it was empty. Now I've raised the voltage up on my adjustable power supply to simulate 12 volt solar panels. They typically put out peak power around 18 to 20 volts. And you'll notice that now we've gone over 16 volts, we are getting the full amperage input limit, so right under 24 amps. So with 12 volt solar panels wired together in parallel, you're going to see about 400 watts peak. So if you use both charging ports and had a bunch of 12 volt solar panels wired together into those in a parallel situation, you'll see around 400 to 500 watts input, just depending on the voltage of your solar panels. And this will take over 6 hours to completely charge the power station if it was empty. Now, how fast would the power station charge if you connected up a 24-volt battery? I have the voltage output to 26.5 volts. We are getting 23 amps input, or right around 600 watts. So you'd charge around 600 watts if you had a 24-volt battery connected. Now, what if you wanted to connect up two 400-watt residential solar panels to the power station? Those are really affordable, and they typically put out around 34 volts at peak output. So if you had one wired into each one of these ports, you could easily get 23 amps, and you'll see that we're almost getting 800 watts charging input on the power station. Now, what combination of voltage and amperage do you need in order to get the 1000 watts input? So if you're looking to build the perfect solar array, you're going to want around 44 volts and 23 amps. And you can see that is giving us the full 1000 watts input. So a combination of series and parallel, or the perfect solar panels in parallel, you're going to want to look for this type of voltage and amperage. Since this power station doesn't support expansion batteries from Jackery, you can connect up your own DIY expansion battery to the solar charging port. It's best to do that with a 48-volt lithium iron phosphate battery. To simulate that, I have it set to 52 volts output, and we are charging a little over 19 amps, and we are getting the full 1000 watts input. So if you wanted to use your own expansion battery, and it was a 48-volt battery, you could charge the power station at the full 1000 watts input to extend the runtime. Now, what about dual charging on the HomePower 3000? We still have 1000 watts going into the DC charging port, but I've just connected the AC charging cable at the same time. Now, if you look at the screen here, we are charging at around 1400 watts input, meaning that it gives priority to DC input first, and then it fills in the rest with AC charging. So this does support dual charging. However, we are only seeing 1400 watts input. Since this is such a large battery, I'd love to see faster charging with both charging inputs connected. Now, just to confirm, in the Smart app, I do have it set to fast charging mode. And being that this is such a large battery, having over 3000 watt hours of capacity, I'd love to see a 0.75 C charging rate, meaning that it would charge at like 2200 watts, but we aren't even charging at a 0.5 C rate. That would be 1500 watts. So in my opinion, this definitely needs to charge faster than 1400 watts, especially when we have both inputs connected. So next, I want to confirm that it allows full pass-through charging. So I have AC charging connected, DC charging connected, and I have the AC inverter turned on, the USB ports, and the DC output turned on. Now, zooming in on the screen, we are getting almost 1800 watts charging input, and we have about a 500 watt load running on the power station through all of the combined outputs. So yes, this does support full pass-through charging. Now let's go ahead and test the solar charging on the HomePower 3000. Now, if you remember, it has a 1000 watt input with a voltage cutoff of 60 volts max. So unfortunately, using larger solar arrays like this 1600 watt array or this 1200 watt array are not going to be possible because the voltage is too high. Now, luckily, I do have a couple portable panels that will work really well with this power station. These are the Zoop W450s. Unfortunately, Jackery did not send out their new Saga 500 for me to test on the power station, but these two solar panels should perform very similarly. Now, as for the solar conditions today, we do have pretty clear skies. There are just a few clouds. I'll make sure I don't test when the clouds are in the way, but it's around 85 degrees. Now, on the side of the HomePower 3000, you have two solar charging ports, which are 80/20 barrel ports. Now, it's really hard to find solar panels with that charging adapter, and this does not come with any solar charging cables to MC4. Now, luckily, the Zoop W450 does come with this adapter that has 80/20 on it. So let's connect it right up and see how much power we get. Now, if we look closer at the screen here, we are getting 863 watts charging input from both of those solar panels. They're rated for 900 watts, and we are getting really close to that full rated power. Now, if you remember, this does take 1000 watts input. So if we're using the Jackery Saga 500s and they put out full rated power, I have seen some videos of them putting out really good power. We get really close to the 1000 watts input on the power station. Now you can see we're just getting a little bit more power here at 867 watts. Now this power station has such a large battery that when you're charging with this rate, it's going to take longer than 3 hours to fully charge it up. And if you add any sort of load to the AC inverter or DC output or USB ports, it's going to take even longer because you have to offset the output going to your loads. So during a 5-hour solar day, which is typical for most areas, it might be pretty difficult to fully charge the power station and run the loads. And that's why I'd like to see usually around 1500 to 1600 watts with the power station of this size. I also tested having solar panels connected overnight on the HomePower 3000. I wired my solar panels in a 2S 2P configuration, and in the morning, once the sun started coming up, the power station started charging. I didn't notice any issues or hear any low voltage alarms during this test, so it's okay to have solar panels connected all the time. I also tested having the power station completely turned off and then connecting solar input. The power station turned on and started charging, so solar panels do wake up the power station if it's died or if it's been turned off. Now let's go ahead and go through a quick demo of the Smart App. So when you open up the Smart App, you do have the ability to see the state of charge at the top of the power station along with the battery temperature. And below that, you see the input and output on the power station, and you can click the DC output to turn it on. You can also click the AC output to turn that on. And then it loads for a second and it'll give you the estimated time remaining, and it'll also give you the voltage in hertz of the inverter, which is pretty cool. Now looking below that, you can see the screen timeout settings. You have the option for 2 hours, 2 minutes, or turning the screen off. Below that, you can see the watt hours accumulated through solar charging and also the carbon reduction. Now there are a bunch of settings, so we'll go into the settings briefly. You can change the name of the power station. You can adjust the charging settings between fast and quiet charging mode. This is kind of an eco mode, so if you have a light load or no load at all, it will turn off the outputs after a given amount of time. I just have that set to never. And below that, you have some unique work modes. For example, you can set the battery settings to fully charge 0 to 100% or less. You can go to self-power mode, which gives a priority to solar input. And then you can do a charging plan based on certain tasks that you set up, whether it's charging at certain times of the day. So that's kind of cool if you have a time of use electrical plan. Now below that, you have your hibernation settings or the auto off time. So if you don't have any outputs enabled on the power station, you can set the power station to turn off automatically. Then you have the serial number and the option to upgrade the firmware. You can see I am running the latest firmware for this video. And then you can see the device specifications that just go through and give all the information about the device. Now just a few more details before I end the video. Now I mentioned in the beginning of the video that this was compact and lightweight. This comes in at 59 pounds or 27 kilograms, which is about 10 pounds to 15 pounds lighter than the competition. So that's actually pretty significant, and also the size is much smaller. Now, one of the biggest advantages of Jackery power stations is their customer support and their warranty. This comes with a 3-year standard warranty plus a 2-year extension when you register it. And out of all the power stations I've tested on the channel, I have the least amount of complaints about customer service with Jackery power stations. So that's definitely saying something about the quality of customer service that you get. So if you're looking for a really good warranty and customer service, then I would recommend looking towards a Jackery product. Well, now that we finished all the tests on the Jackery power station, let's put it through my power station grading system. There are 20 different requirements. Each one's worth a half point for a total score of 10 points available. Now the HomePower 3000 got a final score of 9.5 points out of 10 points available, or an A grade, and it missed out on one of the criteria. And because it has 1,000 watts of solar input and the battery's over 3,000 watt hours, it won't be able to fully charge within 3 hours. Now, if you remember, Jackery is marketing this as a simple plug-and-play home backup system. And yes, it will do that, but does it need to be super compact and lightweight? I'm thinking that it might work best in an overlanding setup or in a van life scenario or even a camping setup. And let me explain why. For a home backup system, usually you need a lot of solar and you need expansion batteries. And this unit right here doesn't have either of those. It only has 1,000 watts of solar, and so your load would have to be really low in order to fully charge the power station and run the load at the same time. And if you wanted to get a longer run time to get through, a couple of cloudy days, or let's say that you have a large load that you want to run at night, without expansion batteries, you can't do that. So I'd say if you're looking for a decent home backup, you might want to look at the Jackery Explorer 5000, which is the larger unit than this, but that has really high solar input and it also has expansion batteries. And I think this one is kind of leaning towards a really good, compact, powerful overlanding or van life scenario. You guys will have to let me know what you think about this power station. Now, a special thanks to Jackery for sending out the power station for this testing and review video so you guys could see how it performed. And make sure you leave a comment down below. I always appreciate your guys' support on the channel. Thank you so much. I'll recommend a couple of the videos that you can check out if you're interested. And until next time, we'll see you guys later.